everyone, this is Festive Tech Calendar 2025. As you've just seen on the welcome screen, this is about hub and spoke scenarios with Virtual WAN. We are the 4th of December, and this is also my daughter's birthday, so happy birthday to Eva. Now let's have a look at the agenda. We will start with a short reminder of what hub and spoke is, and then we'll move to the most simple scenario that we can get with Virtual WAN for hub and spoke. We'll complexify that a bit with a custom route configuration. Before moving to a secure hub with still custom route. And to finish, we will have a fourth scenario, which will be multiple virtual hubs with multiple firewall that we manage in terms of routing with routing intent. So what about hub and spoke concept? Let's have a look at the little schema over there. So when we consider virtual network in Azure, this is mostly to host virtual machine, but it can also be for other virtual network integrated services. For the purpose of simplicity, here we'll keep the scenario with virtual machine. Okay, so here we have one virtual network with two subnets and two virtual machines. The way the virtual network is configured with an IP range at the virtual network level, each subnet that consume range into the virtual network range will allow us to connect virtual machine in each subnet, and this virtual machine will inherit routes so that they can talk to each other without adding any configuration. If we add additional network and we want to have connectivity between those two networks, then we need to add some peering. Okay, and when we add the peering, by the way the peering is configured, we will extend the system route inside the virtual network with routes to the directly connected virtual network. If we add a third virtual network connected to the second one, now we are in a kind of a hub and spoke scenario. So we could have more than two spokes here, but this one in the middle is the hub. Okay, and the hub is used to centralize connectivity, so we can have some services such as authentication, Active Directory, stuff like that. We can also have connectivity with virtual network gateway to connect ourselves to on-premise networking, and we can have different spokes connected to the hub. Do we have connectivity between this hub with this first spoke? Yes. And between the hub and the other spoke? Yes, because by the configuration of the network peering, we get that. Do we have connectivity between VM in one spoke and VM in another spoke? By default, no, because the network peering are not transitive, so that means that we don't get routes for network that are not directly connected to another network. To get routing, we need to add a custom configuration. I have too much detail. No, it's okay. So here I've added on the schema user-defined route, which allows me to modify the routing configuration. So I will add additional information for the routing, stating that for this subnet, the next hop to reach this subnet inside this virtual network is this firewall. So that's why I've written here vnet 1 next hop to vnet 2 is firewall, and the same in reverse. With that, I have connectivity through routing in terms of routing, because I've added another route with something that can be used as kind of a gateway. It could work with a virtual network gateway, but then I would not be able to add some network filtering here, which is one of the aim of the hub, to centralize firewall routing between different spokes without, if we don't want to manage network security groups and network security groups all. Okay, so that's the scenario for OpenSpoke, but as you can see, we need to add user-defined routes in each of the subnets, which is not very practical, neither is it really scalable. So what can we do? If we remove this hub, we can consider the virtual WAN. And the virtual WAN will be somehow very similar to what we had with the virtual network hub, except that we have something much more managed and in a way much more centralized. So now instead of having one virtual network, I have acting as hub, I have one virtual WAN with one virtual hub, and in this virtual hub I get a router on which I have by default one route table. I can connect my spoke to my virtual hub through network connection, which are just virtual network peering but called another name because they are initiated from the virtual hub, which we'll see after that. And then we don't have any user-defined route because the route configuration is propagated from the virtual hub. Okay, that's very theoretical. So let's switch to one virtual WAN with one virtual hub. So this will be to get started this one. So I have one virtual WAN. It will load. Okay, and here we can see that I get, once it's refreshed, okay, one virtual WAN with one virtual hub. Okay, so I can switch on that. I can click on that one before I will open this window because I want to be able to see the virtual network connection after that. Okay, let's switch to the configuration of our virtual hub. So here we are on the virtual hub. We can see that we have the routing status configure. Just on this point, we can see that we can reset the hub. If we want, it would reinitialize the configuration. And if it happens one day to you, you will eventually have this reset router option available if the routing status is in the failed state, which can sometimes happen. I have not seen that very often, but it can happen. We can see that we have two virtual network connection, and then we can see that we have here route table with our default route table. So it's loading, it takes a bit of time. Okay, here I have my default route table, and I should see, if I click on the default route table, some additional information. So here I could add some additional route, but I don't want to do that yet. I can see that I have association with two virtual network, which is the equivalent of the two virtual network connection that we can see here, which are associated to this default route. Okay, if I go back here a little bit back, I will go to effective route, and I should see routes that are visible here, but I will explain where they come from. I need to check the default route table. And then I should see a few routes over there. Yes, okay. Okay, I can see 172.22.1.0/24 and the same 22.0.0/24. Where does it come from? It seems to come from the network connection. So let's have a look at our virtual network. If I go to my virtual network, I should see virtual network, no firewall, single. Okay. and this one comes with the range that I've seen earlier. If I check this second one, I should see that it is 172.1.0/24. Right, perfect. I could also go to the connected device to see that I have one virtual machine in this one. If I check on this one, I also get one virtual machine, which is similar to what we had on our schema over there. My schema was here, so I have this and this. Okay, so again on our console we have two network connections. We can check the configuration. This is a very simple configuration. We just kept everything by default at this point. When we create a network connection, we'll select which table we want to associate. If we want to propagate the route to this route table, and also some configuration with label. So the label we will not consider it for now, but it's interesting to see that at this point what I get is a network connection in which I specify which route table is associated to, and if I propagate the route that I get from the connection. Okay, so here let's switch to the virtual machine and have a look at one of our virtual machine. So I can take this one. I want to have a look at the effective route of the virtual machine this time. To do that, this is not on the virtual machine that I do that. This is on the network interface card. So the network interface card, it should be which one? Single. This is this one. So if I check on this one, I can reduce that. I think if I go in effective route, I will see once it's refreshed. Okay, where it comes. Okay, here I see from the virtual machine network interface card that I have a route for everything that is inside the network. Okay, I also have additional default route. The one that we are interested in are this first one, which is bring by the default, but which is referring to the next hop type as virtual network peering, and it points to 10.100.254.0/23. If I go back to my virtual WAN, not the route that were propagated, but the default configuration, I should see that it does have an IP range which corresponds to what we've seen on that. Okay, so yep, here private IP address space. Okay, if I go into the detail, as a matter of fact, I will see that I consume 2 IP in this range, which are the virtual router IP. What is this used for the rest of those IP? I don't know yet. We'll see that we will probably consume more with the secure hub scenario. But just so you know, Microsoft recommends that we use at least a /24 on that virtual network on that range for the virtual hub, and it is recommended to use a /23, which is quite a lot. But well, okay. What can we do? We can maybe check if we have connectivity with network watcher. Single, yeah, perfect. So this is not the one that I want. I would like to try with the virtual machine 1, and this time I will try to reach this one, because this was the IP that I checked earlier. Well, it was not the IP that I checked earlier. This is this one. It's loading. Here it's also telling me that it will go to the virtual network gateway, which is inside our virtual hub, and it will try to reach one IP, which is not the IP of the virtual router, which is pretty close to it. So I would make the hypothesis that this is a kind of cluster IP for my routers. Okay. So we have connectivity, we have transitivity without adding any routing configuration over there. At this point, so each spoke that is connected to the virtual hub and associated to this default route will see the other spoke already connected. What if we want to have connectivity between some spoke but not some other? Well, we can have a look at that by using a second scenario, which is not this one, but this one, adding custom route. Okay, so if I switch again to my environment, this time I will select another virtual WAN, this one, multiple route table. Okay, and I will check that I have into this virtual WAN, I still have one virtual hub, but if I go into the detail of the virtual hub, I will see that I have more than one route table. So it's refreshing. Okay, let's click on that. In the meantime, let's go back to. Oh, we'll see that afterward. I don't want to see this one. I want to switch back to another virtual one. Okay, here you can see that I have two route tables. Currently associated to the first route table, we have two network connections, and associated to the second route table, I have one connection. If I take a schema about that, if I'm using this one, okay, you can see here that the scenario that we try to achieve is this one. We have a group of yellow spoke and we have a group of blue spoke. The group of blue spoke are connected to the virtual hub with an association to the default route table, and the group of yellow spoke are connected to the virtual hub with the custom route table. The way the route table are configured with propagation of the network that is connected, we will have connectivity for each spoke connected to the same, associated to the same route table. Okay, so that means that if I go here, maybe I can try to go there. I may want to keep that for now. Okay, I can go. Let's go there. Let's go here. So I don't want the route table. I want the virtual network connection. And here I will be able to add a network connection, and then I will check connectivity between my blue spoke and then between my yellow spoke maybe, and definitely between my, I will check that I don't have connectivity between my blue and my yellow spoke, not because I have filtering, but because I have a routing configuration that doesn't manage that. So here I will add a new network connection. I will use this one. I will use this resource group. So multiple RT 24. I will check this one. I will associate to the custom route table, and I will also propagate to the custom route table. And that will be all. So let's create that. Oh, I need to write a name. And I will create my route. Okay, let's check some connectivity. Okay, so in this virtual network, so I have these 4 virtual networks which are connected to my hub. Okay, and in this network I have 1 VM, 2 VM, 3 VM, 4 VM. Okay. If I go here, the virtual machine or the one called multiple. Okay, so let's check this one. So remember, VM in spoke 1 is probably the first blue spoke, and VM in spoke 2 is probably the second blue spoke, and 3 and 4 are the yellow spoke. So if I check the connectivity, I will do run command. I may need to check the IP first. So this is 172.22.1.4. For the next one, it will be 22.2.4 and 22.3.4 if I'm correct. Yes. And yes, okay. So I could do that with network watcher, but I want to do that with a shell script. I will just do a ping. Okay, so I will ping the 172.22.1.4. I forgot to specify that I want 4, and let's do run. In the meantime, my connection is probably being updated. If I'm refreshing here, I should see 4 connections with 1 updating because it's not complete yet. Okay, so let's go back here and wait for the script to execute. Okay, it's working, which makes sense because again, I try to reach from this VM through the virtual WAN, and because I have this route table configured on both connections, they get the route. This is similar to what we've seen earlier. Okay, now I already have 1 virtual machine that is connected because here I have 3 connections. Okay, so if I take this time the virtual network 3, because the virtual network 4 is still in connection, I should see in the connected device the IP of the virtual machine, and I should be able to see that it's not working. Okay, so let's try the same thing, but this time with the 2. Okay, and let's do a run. It should not work. Let's wait for that to execute. In the meantime, we can refresh here to check if it's completed. So yes, it's completed. Okay, here it's not working. Perfect, this is what I expected. Let's try from virtual machine 3. to reach virtual machine 4. This one should work. And it's working, which is what I expected. Okay, let's check Virtual Network Watcher to verify what's happening when I'm trying to reach VM from the blue spoke to VM from the yellow spoke. Okay, so this one I will take, not this one, but this one. I will take VM1. I will try to reach VM2. Okay, so for now it doesn't change. And I should see that the next hop is something like 10.100. Something. Okay. And if I try to reach the 2, I should see a result that tells me that I don't have a route through the virtual WAN. Okay. The result is route table ID system route, and I have a result none, meaning that I have no route. If I go back over there, my route was on this virtual machine. Okay. Let's check the effective route. Taking some time to refresh, but it's always the case with the routing configuration. And so the result that I got earlier is because I have where is it? No, this is not the proper configuration. This is this one. Multiple route table. This is the one that I should get. Multiple RT, sorry. Too many VM, too many scenario. But that's okay. It's taking its precious time to configure. And here I can see that I have this route, which is one of the system routes, so default route from the virtual network, and it's stating that I'm not routing this network, which is one of the RFC 1918 range, unless I add it at the network level. Okay, so that's why I have this result, and that's why from routing configuration we have isolated network in this group and in this group. So that means that with route table on the virtual hub I can isolate spoke together. I do not use network filtering at this point. If I want to do that, this is the next part. So our third scenario is the scenario with custom route table, but this time we add a firewall. What does it look like? Well, something like this. So we still have a virtual WAN with one virtual hub and a virtual router. We still have the default route table, but this time we also add another firewall and a custom route table. And this custom route table will be the one that we use to configure the firewall. So we could use only the default route table, but at this point I don't want to do that. I prefer to separate that with a new custom route, which is something similar to what we did earlier. Okay. So here I on this virtual WAN, which is called RTFW, meaning that we have one firewall. You can see that the icon change. If I go to the welcome screen of the virtual hub, we should see that we have one firewall. We can now go to the virtual network connection. No, I will do the same but by going to the root table. If I go to the root table, I should see that I have two associated connection with one root table in particular. So let's wait for it. Yep, it's updated. Okay, so here I have this root table with two network connection. If I click on this root table, I will see that I have specific root here associated to this root table. So I've added a root so that I force all internet traffic to the firewall that I will see after that, and I have also added another route which force all RFC 1918 ranges to this firewall. This firewall is this one over there. Yes, this is this one. Okay. You can see the IP over there, which is interesting. And then I will go to the network, the related network. So I have this one, which is interesting. I have one connected device. So we'll go to the corresponding NIC, which is RT firewall 1. Perfect. I will see the effective route, and I will be able to identify that I have something different from earlier. Okay, so here on this one I have different route. You can see here that I have route for the RFC 1918 ranges, and we go to the 10.100 and 254.132. So this is the same kind of route that I had earlier, except that it does not bring me a route to the virtual network, to the virtual hub. It goes to this address, which is, if you remember well, the address of the firewall. Why is that? That's because I've added on this route table those routes, and if I go back to my virtual hub and this time to virtual network connection, I can check the connectivity here, the connection, and I will see the configuration of this network connection, and we'll see that it is slightly different in terms of configuration. So here I will do this one, but it will be the same for the other one. And here I'm associated to the custom route table, and this time I've said propagated to none, which means that I do not propagate the route to the connected network to the virtual hub. Okay, so that's why on this one I have the route that comes from the virtual hub, but I don't have any other rule, and it will be the same for this one, which is also connected. I will get the route from the firewall, but I will not get a route to the virtual network that goes without the firewall. Let's wait for it to refresh. can see here that I get the 3 range and also the this one. Okay, so this is quite interesting. So that means that I don't inherit from the network connection a route to the different spokes that do not go to the firewall. Okay, if I check that, I can verify this. If I check the RT firewall, perfect. I can check the first VM, and I can check that if I want to access the second VM. Let's do a next hop. And I will have the same result. It goes through the firewall. Okay, seems correct. I want to verify that because I do not trust it, so I will generate some traffic and then I will check the log of my firewall. Shell script over there. So let's do a ping. And see 122.22.1.4. Yep, let's run that. It should work. And then we'll check the firewall. Oh yeah, again. And it's working as expected. Let's check the log of the firewall now, because I want to be sure that it's working, right? Let's do this. Yes, I can do that maybe. So I can see that I have traffic between my virtual machine 1 and virtual machine 2, 172. Oh, this one is probably something that I did but it was not working. But I can see that I do go through my firewall. Let's remove that and just see the details. Can see some details here. If I check source IP, destination IP is 1.4, okay, and can I see maybe I can do that. I have less traffic, okay, perfect, and this time I have an ICMP traffic, perfect. So this is the traffic that I did earlier, okay. So the firewall configured with allowed all rule, which is not ideal, but this is for the purpose of this lab, okay. So let's go back over there. So what I change from the network configuration earlier, the network connection, is this one, propagate to none. So that means that when I do that, I do connect, but I do not propagate the route to the connected network to the hub route table, and that's why, unless I've specified on my custom route that will go through the firewall, I won't have any way of giving the virtual machine connected to the spoke connected to the hub route to the other spoke. But this way I can. Okay, so that's quite ideal. It works fine with one virtual hub, what happens if you want to have more than one virtual hub with firewall. This is my last scenario, and after that we'll be finished, which will be okay because it was quite a long track, but okay. So let's go back to the schema. So this time we don't have, I see we still have a secure hub, but we will have also a second virtual hub. Okay, so by default, that's also why the virtual hub are interesting. We have automated peering between the virtual hub if they are in different region or either they are in the same region. Also, if we add a second secure hub, we need to think about something else. So this custom route table that we use in the first case, it will not be kept at this point, so let's move it somewhere else. We can remove it maybe. Okay, so on this scenario we have, well, we will have more than two spokes, but if we have only two spokes connected together, one connected to this virtual hub and one connected to this other virtual hub, if we want to have two firewall, we cannot use custom route because, again, let's have a look over there. If we check this network connection, we will not check the network connection, but we check the route. Let's go to the hub. Okay, and the route table. So what we did earlier is, instead of having the automated routing configuration, so we still have centralized configuration, but it's not automated anymore, as in the first scenarios. In this one, we have modified the way the route table works. Okay, because we've added on this route table specific route, which could be assimilated to static route that are inherited by our virtual network. Okay, so this one and this one. It works fine, as I said, as long as we have one virtual hub and one firewall. But if we have two virtual hub and two firewall, there is something that is not written here. We cannot configure the firewall from another hub in the route table associated to run one virtual hub. So if I go here on this route table, or the custom route table, I cannot say that to reach this virtual network I will need to go to this firewall. It doesn't work. It failed, as a matter of fact, so don't do that. I've done it for you. It failed miserably, and we need to reset the configuration to make it work correctly. Okay, so we cannot specify that from this one, using this route table, this spoke using this route table, we cannot tell it that to reach this other spoke which is connected to another virtual hub, it should go through this firewall, because we've changed the routing, and so the routing configuration with a custom route table or a route table using a static route cannot use a next hop with a firewall which is not in the same virtual hub. So what can we do? Well, we can use routing intent. So for routing intent, let's switch over there. Let's go back to the virtual WAN, and this time we'll go to the virtual WAN over there. So in this virtual WAN, I have two virtual hubs. Okay, you can see that those are virtual hub with the little icons for the secure hub. Okay, let's wait for it to refresh. One firewall. If I go to the route table, you will see that I have only one route, and it will be the same for the second virtual hub. Trust me on that. it's taking some time to load. Okay, so I have one route with an associated with 3 associated connection, and this time, because I did not use static route, I used routing intent, and in routing intent I specified that I want to go to the firewall for the internet traffic or the private traffic, and I specified the local firewall. Okay, I can only specify that. I cannot specify additional prefix for the private traffic, but with this routing intent, it means that I keep the default route table, but I have a routing intent and routing policy that I use to route the traffic for specific traffic, specific destination range to the firewall. That means that if I go to the effective routes, I will not see something similar to what I had earlier, but I will see normally a few additional things. So let's wait for it to refresh. If I do that, it's loading, and I get the routes to the virtual network connection. Okay, the next hop is network connection. Perfect. We can see the remote hub, which is the second hub, and we can see the internet. If I check the route table, is it different? Default. Okay, and here this time we can see that for the remote hub I go to the next hub, okay, but to the connection I will go to the network configuration. So the firewall does not appear here, but it's still used. I will verify that. How can I verify that? By going to the virtual machine over there. So if I go this time to, well, this one maybe, so you can see that I have 6 connected virtual network. Let's just have a look at that. If I go to the virtual hub, yep, I want to check that. Okay, I go to the network connection. I have more network connected in here, but that's okay. So I can simulate more traffic. Okay, here I have 2 connections on the virtual hub, and I have this one also. Okay, perfect. But we can see that we have routing property, routing intent that I've checked earlier. Okay, so now I can go over there to my virtual machine, and I can do some shell script just to ping some traffic. C4, can do some this one 22.2.4, and I can also do C4 172.5.4. Okay, let's run that in the meantime, because I also use some other firewall. So I have the firewall on the hub, the first hub, and the firewall on the second hub. So let's check the traffic on this one first, and then let's check the traffic from the other one. Okay, so connected to this one, I have the virtual machine with the IP address 172.22.068, and I also have the probably the 2.4, and connected to this one I have the probably the 4 and the 5. I will check the logs. I will do this one. I can see that I have traffic with destination IP either being the 172.22.068 or the 2, as I mentioned earlier, and I also have the 3, the 4 and the 5, which are connected to the other virtual hub. I can check that also to verify that on the second firewall. Same command, same request, and I should see the traffic also going through this firewall, which means this one. Perfect. So I have a little bit more traffic. I will not focus on this one, but on this one. So 24053. So I do have traffic that goes through all firewalls, so that makes sense. So that means that I have 2 levels of firewall, and if one spoke is connected to one hub with one firewall, if you reach another spoke connected to the same hub, it will go through one firewall. If it tries to reach another spoke which is connected to the second virtual hub with another firewall, it will go through the 2 firewall. Maybe I can run a network watcher before finishing that. So let's change. This is this subscription this time. No. Which one is it? It doesn't seem to be able to do that, but that's okay. So I've seen what I wanted to see. In this last scenario, I'm able to use 2 levels of firewall for spoke connected to different virtual hub. It's interesting if I want to have 2 firewall for any reason. Also, if I have 2 virtual hub in different regions, then the spoke are connected to the local virtual hub, and then if they need to reach another hub in another region or a spoke in another region, they will go through the other spoke to the other hub, and they will go through both firewall. But that's only possible if we use routing intent, as we've discussed earlier. So that means that we are at the end of this presentation. So that's the end for me. What we've seen in this presentation is different scenario for hub and spoke. The most simple one is just one virtual hub, not much configuration, and it brings us a very simple scenario like that, something like that. Okay. No user-defined route in each subnet. We don't need that anymore. It's centralized. Then we go to the secure hub. Either we use a custom route table, but if we want to have more simplicity and probably more scalability after that, we should maybe probably use routing intent instead of the schema is here, instead of the custom route table, and that's all. Okay, so next is the thank you note over there, and then that's it for me. Have a good day and thank you. Bye.